Okay, so the material that we're getting into, we're talking about domain and range. We already discussed domain and range last semester. Who can refresh our memory as to what domain stands for? So when we're talking about domain, who can tell me what values are we calling domain? Matthew? X, right? And what's another word for the domain? There was another word that we used sometimes. Anybody know? Going once, twice? What do you think? Input. Very good, Mason. So up at the top, I want you guys to write down so that you remember that our domain is another way of saying input. And that's just going to be your X values. Okay, so when we are looking at it graphically, we're talking about our X-axis. And then you've got the range, which is the complete opposite. So range is going to be your output. So once you plug your X in, the value that you receive, or that it yields, is going to be your output. And that represents your Y values. Okay, so just as that reminder, there's also a couple of things that I want you guys to have an understanding of when we talk about different graphs. You're going to hear me talking about continuous versus discrete. So when we get to a couple examples, I'll tell you what that means in just a moment. But with our domains, what we're doing now, instead of just saying, oh, domain's X, and I'm going to plug it into a linear expression and then solve, or an algebraic expression and solve to get my Y. For these, you're now looking at graphical representations that are related to a context, related to a word problem, and then you're identifying what ranges of domain and what range values of the range, so basically what intervals of domain and intervals of range would make sense in the context of the problem. So for example here, Elena filled up the tub and gave her dog a bath. Then she let the water out of the tub. So this is going to represent her filling up the tub, giving the bath, and then draining the tub over the period of time. So at any point, can our values go into negative? Why not? Huh? But tell me why can't my X ever be a zero or a negative value? Like, why can't it ever go into a negative? Jai?
Because it can't go under the tub.
Well, that's right now I'm focusing on my X. Why can't my X ever go to a negative? Kaden?
Because you can't go back.
The zero, like in your AC, like it goes up.
Okay, anybody else? Why can't my X be a negative? DJ? Because time can't be negative. What does X represent? X represents time. It represents minutes. Can you have negative minutes? No. And then like Jai was saying, you can't have water going below the tub, right? Like the water level isn't going to go below the tub. Obviously, yes, we know it goes into the pipes and it's draining below, but the water level of the tub is either going to have to be at zero, meaning that there is no water in the tub, or higher. Now, when it caps off at a certain point, can my water level forever be going up and up and up and up and up in the tub? Why not? Because it'll spill over, right? So that does have a point in which you no longer can fill that tub up anymore. Okay, it's at the highest level it could possibly be. Okay, I don't know if you guys ever did that as a kid. Anybody ever try to like overflow their tub? Like they turn the water on, try to see how high they could get the tub up. It gets to a point where it doesn't even get to the top of the tub level. It gets to a point where there's that little safety drain. You guys know that little circle drain that's on the side of the tub? That's a safety drain. It keeps it from overflowing. Okay, so you've got the drain at the bottom, you've got the safety drain at the side. So it has a point at which you no longer can fill that tub up. So these are what we're talking about, that there are specific values that represent your domain, your minutes in this case, and your range, the amount of water that's in that tub. And you can't be outside of those values. Okay, you can't go into negative values, or there's only so much positive value that you can be. Okay, so here in this case, when we're talking about the range again is focusing on the volume of the water. So I'm going to go ahead and highlight or underline range with my pink, and I'm going to go ahead and put a pink box around the volume of the water. So range is what's focusing on going as far up or far down on your y-axis as you can. So what is the lowest y? The lowest y value that our range can be, Eker? 0. The lowest y value that we can have is right here at 0. See, if we look at our line is starting at 0, and at the very end, it ends over here at 0 for our y. Remember, our y is the value that's going up and down. That's our y-axis. So the lowest that our y can get to is going to be a value of 0. Okay, what about the max? The maximum value of our y in this situation is at what, Caleb? Look again, honey. Not just the, nope, look again, look at the line. Where is the cap off of our line at, honey? 24, right? The cap off for what we've just graphed here is over at 24. Okay, so the maximum amount that we're going to in this situation, in this graphed situation, is 24. So now when we are looking at that, we like to, because it's a range of values, okay, it's an interval of values, we're going to use inequalities to represent that situation. So when we're saying that the lowest point is going to be 0, that means that y can be greater than or equal to 0. When we're saying the maximum amount that our y can be is 24, we're saying that y can be less than or equal to 24. Now, I want to put these together, though. I don't want to have two separate stated inequalities, so we're going to make it a compound inequality. Remember, with compound inequalities, one of those inequalities is just going to be flipped, and then you can piece it all together. So we're going to go ahead and flip the y is greater than or equal to 0. If I want to flip it, it would now become 0 is less than or equal to y. That's the exact same thing, isn't it? If y is greater than or equal to 0, then 0 is less than or equal to y. Okay, the inequality is still pointing in the same manner. It's pointing towards the same value as it was. You're just flipping it. And then I can piece this together. Now I know y is less than or equal to 24, so I could put less than or equal to 24. There's my inequality, my compound inequality that is going to represent the range of this function. Okay, and then what does it represent in context? It just represents the volume of the water in gallons. This is volume of water. Okay, that's all that it's representing. We're representing the volume of the water in gallons that are going to be in that tub. Okay, now we're going to do the same thing for what was graphed for the domain. Now remember, the domain is going to be our x. That's going to represent the time in minutes. So the domain of the function is representing the time in minutes that we're going to be able to go ahead and graph. So in this case, again, we want to know what is the minimum, the lowest amount, our min, for our x value. What's the smallest amount our x is going to be able to be? 0, right? The smallest amount, this is where we're starting off at right here. The smallest amount is going to happen to be at the value of 0. And then what is the maximum amount that our x is being graphed at? Eker? 30, right? We're stopping right over here at 30. Okay, so again, if we were to write this, we've got that x is going to have to be greater than or equal to 0. It does start at 0. Right? 0 is included as part of the time. And also the maximum x is going to be less than or equal to 30. It can be equal to 30 or it can be less than 30. Okay? If we were to write that as a compound inequality, all we have to do is flip one of them. We typically flip the one that's going to be on the left side. So we're going to rewrite and flip this. So instead of it saying x is greater than or equal to 0, we're going to say that 0 is less than or equal to x. And then we piece this with it, which is less than or equal to 30. Okay? And then what does the x represent again? The minutes, right? The time. So x is the time. in minutes. All right, so all we are doing is we are just indicating that interval that's going to represent each of our domains and range values. And then from there, we can identify which possible numbers or which possible values could be a representation of the range or could be a representation of the domain. Okay, now in this situation, this is a graphing story in which it does have a starting and stopping point. Some of your other ones are not going to have starting and stopping points, and they are just basically indicating that they are going on in a continuous manner. They're going to go on forever. So like, for example, this last problem down here, even though it does only have a few positions plotted, the scenario is indicating that it can keep going because the scenario is talking about going to the barbershop and getting haircuts. Is there a finite position of which we're like, oh, after this point, she will no longer ever give haircuts again? No, she can continue going on and giving haircuts as long as she pleases. Okay, so those are ones in which you have to understand that they can keep going. Okay, now I told you before that I wanted to tell you about continuous versus discrete. So continuous, when we're talking about a function that is continuous, think of the word connected. Continuous means that you are all values from one point to the next and anything in between. So here, I know I've got a value at 0, 350. I also know I have a value at 2 and 300. But I also have values that are all the way in between those because those lines are representing everything that's connected in between. It's kind of like a number line. If I'm saying, oh, you can get anything between a 70 and an 80, then that means you can get a 71, you can get a 71.5, you can get a 71.287, anything that's in between those 2 points. Okay, that's what makes it continuous. They're connected together as a straight line. Versus here, this is called discrete. It means it's dotted points. It's very distinct values. So I do not have any values between these dots. Anything in between them does not exist. It's not a part of it. So it's very discrete and exact measurements, very specific measurements. Okay, so continuous, connected, discrete is dotted. Everybody get that? Okay. So here, what we're going to do is we're going to go through with this one. We've got a 350-gallon tank full of water is draining at a rate of 25 gallons per minute. And the graph represents the relationship between the gallons of water in the tank and the minutes that the tank has been draining. So again, just like our previous problem, once it's drained, it has no water left in it. It can't go into a negative. So we're talking about minutes, can't have negatives for minutes. And we're talking about the number of gallons, can't have negatives for gallons. So right off the bat, if I'm looking at these values, which value can I get rid of if they're asking me to identify possible inputs? Well, first of all, input is which one? Is it gallons or minutes? Minutes, right? Input is going to be our minutes here. We're talking about minutes for our input. Remember that gallons is going to be our output. That's our Y. That would be our range. This is our domain. This is our input, number of minutes. So can we have negative minutes here? No. So what value can I say is not possible? Negative 4. Negative 4 is not possible because of the fact that it's a negative. So we're going to go ahead and put that down here in the impossible input area. Okay. Now, we're going to go through each of these and identify whether or not this is a possible value for our graph. 15. Is 15 a possibility for our graph? Some people are saying yes, some people are saying no. Woo! Okay, so now remember when we're talking about our graph, are we just talking about the grid or are we talking about the line? The line. Does the line go to 15? No. The line stops at what? 14. The line stops at 14. That means at 14 minutes, the tank is no longer got water in it. So are you draining anymore? No. Yes, there are 15 minutes and 16 minutes beyond the 14-minute mark, but at that point, we're done with the job. The tub has been drained or the tank has been drained. It no longer has water. We no longer are counting that as part of our time. So 15 minutes is too large. It's larger than the expectation of what we're wanting. It's larger than the expectation because right here, if we're looking at our range is going from 0 to 14, isn't it? Not our range, our domain. Our domain is going to be that x can be greater than or equal to 0, and that x can be less than or equal to 14. We know that. So if I put it all together, it would be 0 is less than or equal to x, which is less than or equal to 14. So that means I am looking for values that are in between 0 and 14. It can be equal to 0, it can be equal to 14, it can be anything in between. It cannot be anything outside of that range though. Okay, so 15 is outside of that range or outside of that interval. We don't let that be part of it. So 15 is going to go in the impossible box. What about 2.7? Yeah, it's in between these values, isn't it? Okay, and again, this is continuous. So that means that even though it's a decimal or a fraction, it still is a part of those values. It's not discrete or dotted or specific data. It's everything in between. So 2.7 is a possible value of minutes. What about 0? Yeah, right? It says greater than or equal to 0. 0 is a possibility. Okay, we already said -4 is not. That's going to be a negative. So that doesn't work, that doesn't work. 2.7 works, 0 works. What about 10? Does 10 work? Yeah, 10 is going to work. It's in between the values of 0 and 14. What about a half? Does that work? Yeah. It's greater than 0, it's less than 14. Those all work. Okay? So these are values that are going to be possible input values. Okay, what I want you guys to do now is do the same thing for this problem. Okay, in this problem, she is going to do her career as a barber or a hairdresser. She borrows $100 from her uncle to buy her supplies. So that's this graph. The graph compares the number of haircuts and her profit as she works her way to paying her uncle back. So why are we down here in the negatives? Who can tell us why? Why are we in the negatives right now, Cole?
She's in debt 100.
She's in debt $100, right? She owes $100. Why is this able to be discrete data? Why can't I connect this together? Look at what it's called. Look at our labels. Why are we not allowed to have this be continuous data or connected data? Why does it have to be very discrete or distinct data? Why do you think, Caleb? What could be negative? The profit? Yeah, profit could be negative, but that doesn't describe why it can be distinct or, specific values. Why is this dotted? Why can't I connect between these two? What do you think, Jai?
Because you can't have like half a haircut.
Exactly. The haircuts. You cannot have half of a haircut. Once you cut a piece of hair, that's a haircut. Right? Even if they don't finish the whole job, it's a haircut. You went in, you got a haircut. It might not be what you wanted, or it might not be as long or short as you wanted it. It's still a haircut. So once she does the job, the haircut is a haircut. There's no half of a haircut. There's no, a quarter of a haircut. There's no decimal value of a haircut. So the haircut has to be very specific whole number values that she's providing. Okay? So with that in mind, I want you to go through these. Again, we're still talking about our inputs. These are our inputs, the number of haircuts that she can provide. That's our input. I want you to tell me which one of these values is possible values for the input and which ones would not be possible values for the input. All right. Possible inputs, possible values, or possible number of haircuts. Can she give 15 haircuts? Yes. She can give 15 haircuts. Like I said, even though it's not positioned here, there are some in which it's implied that it's just going to keep going on and on and on based off of the fact that, yes, you can continue giving haircuts and receiving profit in her job. So even though it's not graphed here, 15 haircuts is still a possible input. What about 2.7 haircuts? No, can't give a decimal amount of haircuts. What about 0 haircuts? Yeah, she can give 0 haircuts, perfectly fine. What about -4? No. What about 10? Yep. And what about a half a haircut? No. Okay, so let's move on. Go ahead and flip it on over to the back. So we have a submarine. Submarine is 900 feet below the ocean. It slowly starts to ascend at a speed of 150 feet every 10 minutes. Every 10 minutes. So we've got the depth in feet and we've got the time in minutes. So can we ever go into the negative range for the minutes? No, we can't. So we cannot graph anything over in these quadrants at all. Quadrant 2 and quadrant 3 are going to stay empty. But we can have negative depth, right? In fact, the fact that they are 900 feet below the ocean, that is indicating a depth of a negative value. That would be at 0 minutes before they start doing any of their ascending. At 0 minutes, they're at 900 feet. So we can go ahead and graph that right here. So using that information, we're going to sketch that graph. Now they're saying that we're going to go ahead and increase 150 feet every 10 minutes, right? We're going to ascend. That's an increase. So at 10 minutes, if we increase from negative 900, we increase by 150. Where is that going to put us? If we increase by 150, where is that going to put us, DJ? Negative 750, right? So at 10 minutes, we'll be halfway between the 900 and 600 mark. That's at negative 750. And then it's going to keep doing that. After another 10 minutes, we'll then be at negative 600. After another 10 minutes, we'll be at negative 450. After another 10 minutes, we'll be at negative 300. After another 10 minutes, we'll be at negative 150. And then at another 10 minutes, we'll be at 0. Can we go any higher than that? No. That's as high as we're going to be able to go. Now, am I going to keep this as dotted discrete data, or am I going to connect them? Discrete or connected? Connected. You're going to connect them because you do have time in between here, right? It's not like, oh, 10 minutes. And then, bam, we go to another 10 minutes and there's nothing in between. No, you've got minutes that are in between there, just the same as you've got depth that's in between the negative 900 and the negative 750. So we are going to connect that information together. That is going to be a continuous data set that is being plotted here. Now, this is the maximum that we're able to go to. That's the stopping point. It cannot go any further than that. Okay? So we've sketched it. Now, what is the slope of the equation? The slope of the equation is the rise over the run, right? It's our rise over our run. So how much are we rising? How much are we increasing by each interval? 150. And then how much are we running by for each interval? 10. And so when we simplify that, 150 over 10 comes out to 15. So that represents 15 feet per minute. It's 15 feet per minute. Now, the y-intercept, what is the y-intercept? Negative 900. And that is the negative 900 feet as the starting depth. Okay, and then modeling the scenario, we can write this now as an equation where we can write it in slope-intercept form, right? So we have y is equal to our slope, which was 15, times x, and then plus or minus our b. Well, it's a negative, so it's going to be a minus, so we're going to put minus 900. So there's our equation. All right. So what is the x x-intercept. I know we just discussed the y-intercept, but now what does that make our x-intercept? Mason? 60 what? 60 minutes to get to sea level, right? It's going to be 60, which represents the minutes it takes to get to sea level. Right? Our y-intercept was talking about depth because that's what our y value represents. Our y value represents the depth of the submarine. Our x-intercept represents our x values, which is the minutes that it's going to take for us to get to a certain level. Caleb, do you have a question?
We're not doing number one, right?
We already did number one. We sketched the graph, right? That was number one, was sketching the graph. Okay? All right, number 5, what is the range of this graph based on the scenario? So the range of the graph, meaning the lowest to the highest point. And we want to write it as an interval. Okay, we want to write it as an inequality, a compound inequality. What is that compound inequality going to be? For the range, remember range is going to be the depth. So going from this point up to this point, what is our range interval? Eker? Very good. Negative 900 is less than or equal to y, which is less than or equal to 0, right? This indicates that our y value starts at negative 900, but then can continue to go greater than it until we get to the 0 mark, which is our maximum level that the submarine can get to. Okay? What about the domain? What is the domain's interval going to be? So remember, the domain is starting here and it's ending here. Okay, so our domain is our values for our x. So what is that interval going to be? Jai?
0 is less than or equal to x, which is also less than or equal to 60.
Very good. 0 is less than or equal to x because x is the minimum value that our time can represent. And then 60 is the maximum amount of time that it takes the submarine to get up to its sea level. So 0 is less than or equal to x, which is less than or equal to 60. Okay, we're actually going to skip this last one right here because I would like to go to the last page where you're going to be practicing just writing these intervals for our domains and our range. So we're going to go ahead and move to this last page. I'm going to do the first 2 with you. I'm going to do the first 2 responses with you, and then you're going to do the remainder on your own. We'll check over it before class is over. But again, remember, domain is going to showcase to us our x expansion, right? So all we're doing is identifying the domain in this case. So for our domain, we're just identifying how far our x can move from left to right based off the plotted positions. So our domain starts here at this dot and ends at this dot. So it's just for our x's. So we're going to follow this up until we get to where the values represent. So this value is represented at negative 10, and this value is represented at positive 6. That means that my domain is in between these values. And notice that these dots are filled in, aren't they? These dots are actually filled in, so that means that they are equal to. They are equal to. So I know that my x can be greater than or equal to negative 10, and that my x can also be less than or equal to 6. So now I need to put them together. Which one of them am I going to flip? The negative 10 or the 6? The negative 10. So we're going to flip this. Instead of saying x is greater than or equal to negative 10, we're going to say that negative 10 is less than or equal to x, and then we piece the second part, less than or equal to 6. So there is my inequality, compound inequality. Now, I would like to go ahead. I'm going to skip number 3 because I want to go to number 4. because number 4 is talking about range, but it also has, if you notice, some of the dots are filled in and some are not. If it's not filled in, then we don't put the equal to. Okay, if it's not filled in, we don't put the equal to. Now remember, range is going to discuss our y. So our y goes up and down. Our y is going to be the value that goes up and down. So you're talking about the highest point that our range can go to and the lowest point that our range can go to. Oh, well, I guess in this case it doesn't really matter about the dots, because the dots are your starting and stopping point for your domain. But here our highest point is going to go to what value? 8. Our lowest point on the graph is going to go to what value? -2. Okay, so I know that y is going to have to be greater than or equal to -2, but it also is going to have to be less than or equal to a positive 8. Okay, greater than or equal to -2, but it also has to be less than or equal to a positive 8. So that means we can flip-flop this one. -2 is less than or equal to y, which is less than or equal to 8. Now, if this was domain, this would be a greater than or equal to sign. This would be a less than sign. Okay, remember, open circles are just less than or greater than, no equal to underneath. Okay, I want you guys to do number 3, or yeah, number 2, number 3, and then on the back is 4, 5, or is 5, 6, 7, 8. Go ahead and do those real quickly. Okay, so for problem number 3, or sorry, we'll do number 2 first. Problem number 2, finding the range, that means the y values. The lowest point that y was at was -8. The highest point that y got to was -1. So your inequality should be -8 is less than or equal to y, which is less than or equal to -1. Okay, let's take a look at number 3. For problem 3, that was also a range. The lowest point was at 0, the highest point was at 7. So you would get 0 is less than or equal to y, which is less than or equal to 7. That was for number 3. Okay, flip it on over to the back. We're going to go over for problem number 5. For problem 5, that was a domain problem. Notice that these 2 dots are open dots. That means that they are not equal to's underneath. It has to be just greater thans or less thans, no equal to's. The smallest value, the lowest value is -9. The highest value is positive 8. So we get -9 is less than x, which is less than 8. Going down to number 6, that was a range question for number 6. The lowest point was -6, the highest point was positive 1. So you have -6 is less than or equal to y, which is less than or equal to 1. That's for problem 6. Problem 7 was a range value. Highest point was at 2, lowest point was at -5, so you get -5 is less than or equal to y, which is less than or equal to 2. And then for number 8, your domain, you have 2 closed circles. Those closed circles mean that they will include. So you have -10 is less than or equal to x, which is less than or equal to 11. Tomorrow, when you come into class, you're going to be doing a delta math. That's a quick one, just practicing this. Okay, it'll be just a couple of questions practicing this skill only.